Good morning, everyone. Thank you very much for joining us in this breakout session. And the topic of discussion today is Spirit AeroSystems Factory of the Future, powered by AWS. Let me start off with an introduction.
I'm Pierre Harder. I'm Director of Advanced Manufacturing Strategy and Systems at Spirit AeroSystems.
And my name is Subhash Chalpan. I'm a Senior Manager with the Digital Supply Networks practice at Deloitte Consulting. Let me set the broader context for this topic and what brought about the discussion today. It shouldn't come as a surprise to all of us that information on demand, insights on demand is now normal in our workplace and in our lives. It is what we're accustomed to with all the applications that we work with, and in the smart factory setting, that has become much more prevalent. We need information on what's happening in real time, and you couple that along with macroeconomic uncertainty and all those other technology-driven disruptors out there in the market, it's now a very competitive landscape. And companies and business stakeholders within smart factories or factories in general are looking at what are those key differentiators, what can we do in this digital transformation space to stay one step ahead? And how do we think about bringing in different pieces of existing technology and coupling that together with new solutions and rapidly creating a solution that drives value out in their factory floor? So today, Pierre and I will be talking about a real-world example at Spirit AeroSystems. And we'll talk about how Deloitte and Spirit came together and harnessed the power of AWS to develop that solution for the factory floor.
All right, so before we dive into the particular solution, I want to give you a little bit of context. Excuse me. So who is Spirit AeroSystems? Anybody ever heard of us? So we are not Spirit Airlines, which many people think we are. So if you flew in on a yellow airplane, that's not us. But if you flew in on a commercial airplane, you likely flew on product that we build. So Spirit AeroSystems is a global tier 1 aerostructure company. We're the largest in the world. We have over 15,000 employees. Over 1,000 of those are engineers. We have last year's revenues were $7.2 billion. And we're seeing unprecedented growth in the airline market over the last 10 years. It's grown at a cost-adjusted growth rate of over 7% over the last 10 years, and we see that growth continuing on for the foreseeable future. Our revenue mix is broken into 3 different categories. First of all is fuselage, so we make mid, forward, and aft fuselages for many of the world's most popular aircraft, and we'll show you some of those on a future slide. About a quarter of our revenue is broken up into propulsion systems, so that's pylons, thrust reversers, engine cowlings. And the remaining quarter, or thereabouts, is wing components, so forward, leading edge, fixed and movable surfaces, as well as control surfaces in the wing components. We've got a mix of commercial and defense. Roughly 85% of our revenue is from commercial aircrafts. But we have a growing defense lineup. Several of the programs you see down there, the Sikorsky CH-53 heavy lift helicopter, the P-8, which is a defense derivative of the commercial Boeing 737, and the KC-46 tanker, which is a commercial derivative, or which is the defense derivative of the commercial Boeing 767. And we're also proud to be one of the 7 major partners on Northrop Grumman's B-21 program. So next we're going to show you a small video, about 90 seconds in length, that we think is inspiring, and we believe it's going to give you some insights into the realities of our manufacturing environment, as well as show you some snippets from the solution that we're going to talk about today.
The world is changing, and you have to stay competitive. If you don't stay competitive, then you may not exist.
This is one of the first projects in our engineered factory vision, and it's really exciting because we see it as transforming the way that not only Spirit does business in aerospace, but really how aerospace in general does business.
We have become so ingrained in what we've done for the last 50 years that by bringing in this new digital age, there's so many other things that can be linked to it, giving us a better chance to identify where our bottlenecks are and plan for our future.
Aerospace as an industry haven't really caught up with technology maturity. There's no full synchronization of processes end to end. That's what we overcome with this small project.
There was a key business challenge that was brought up in that video, which was adjusting to constraints. The idea of adjusting production to meet real-time events or real-time constraints. And that can be brought about by three particular components, which is people, parts, and the underlying process. How do we design a solution around those constraints and ensure that we're continuously producing, given the right timelines and due dates and given the master schedules, in the right time frame and utilizing the right resources? Having that information, having the ability to look into your overall systems and make those decisions at a rapid pace, that's what's driving the need for a smart factory solution. And this is very common in smart factories, right? How do we increase employee engagement? How do we ensure they tightly couple with the process, they integrate with that process, and ultimately having that information visibility? And that helps us solve complex issues that I just spoke about with constraints. But a complex solution like that requires a complex platform that's able to incorporate different pieces of data, different application information, and the underlying business logic. So we'll see how complex these programs get, and we will dive into the actual technology components that went into building the solution.
So before we go into the particular solution, let me give you a little more context into what the complexities of the aerospace manufacturing environment are. So as you can see in the pictures on the left there, the blue components of all those airplanes are the structures that Spirit AeroSystems build. So as you can see, we have a significant share of the best programs that are available in commercial aerospace today. So a little bit on complexities. Complexities in aerospace manufacturing can really be bucketed in 4 different buckets. First of all, especially with Spirit AeroSystems, we have the complexity of the different platforms. All these different airplanes have different requirements. Couple that with the requirements that come from each of the different OEM manufacturers, Boeing, Airbus, and the different regional jet manufacturers and defense OEMs as well. So all of those bring a complexity not only from the distinct differences of the products, but from the requirements from the manufacturers as well. Second is part size. So we're dealing with very large components here. For example, the 737 fuselage that we build that and ship it in one complete tube that's shipped from our Wichita, Kansas headquarters to Seattle on a train. So a lot of our components are shipped by train. We also ship by boat from our North Carolina plant. We build the center section panels of the A350 Airbus airplane, which are composite panels. Those ship across the sea to our France site. The next level of complexity really is part count. So using that 737 fuselage as an example, there's over 25,000 different parts that go into a shipped fuselage. Couple that with about 250,000 fasteners that we install before we ship that as well. So there's a lot of complexity when it comes to part count. And finally is the supply chain complexity. So we have operations. Spirit has sites at 7 different sites globally. Wichita, Kansas is the headquarters, North Carolina, Scotland, Sabang, Malaysia, and Oklahoma. You couple that with a global supply chain of over 1,000 different suppliers, and then couple that with long lead time items like titanium and composite materials in aerospace that often can be over 60 weeks or more of lead time. So that brings an additional layer of complexity into the solutions that we have to bring to bear. So looking at all those complexities, we wanted to embrace a solution that could bring together all those solutions and enable the mechanics on the shop floor to reduce the complexity in their daily lives. And that's really enabled by the digital thread.
Perfect. The digital thread, everyone sees it and interprets that in their own respective ways. How we see a digital thread is it's an ever-evolving platform. You don't just build something to address current issues, but you build it thinking about what are the future issues that we'll have to solve. In this instance, we're talking about solving issues of finding parts, for example, on a factory floor. But you also have to be able to create a platform that's nimble enough to incorporate future supply chain challenges or solutions that you would like to build around that. And for Spirit, for example, we built the digital thread with 4 main components. That was the foundational pieces. The first was a dynamic production scheduling algorithm. Now, what this does is it goes back to the constraints management principles that we spoke about earlier, people, parts, and process. It's about understanding how you prioritize your orders based on those constraints in real time. Do you want to work on the right order numbers or the right jobs? Or, if you don't have the inventory, should you just put it aside for now until you get a complete ship set and then continue working on it? Second is machine monitoring. You have to identify which machines are available to be worked on in the first place. And if you're scheduling parts to be ran on machines at the wrong times, then you have officially built up a huge backlog of inventory. And the third component is material visibility. Understanding where the parts are within these huge facilities, tracking them, and then bringing them to the right machines, or staging them in front of the right machines so that they can run at the right time. And having a right tracking solution creates that fundamental digital thread in tracking materials and parts along the way. And the fourth, of course, is a command center or a conveyance tool, where you bring in all this information in an elegant way so that operators and mechanics can interface with it on the factory floor and just have an easier time looking at the landscape of their facility, understanding where the parts are, what they need to be working on without taking too much of their time in their day to figure out that whole process. Now, the digital thread, as I said, has to continuously evolve. And we have built it in such a way that it actually incorporates not just these 4 components, but also Spirit's engineered factory principles.
So the project we're going to talk to you about today is called FloorSight. Before we get into the details of that, we really want to talk about the broader portfolio of projects that we're using to transform the way we do work. There's about 50 projects. One of them is on the screen here. It's a new production system that we just finished 100% design review on that'll go into operations next year. And this is going to create floor beam assemblies. So there's over 250 different variants of floor beams that go on a fuselage, a single fuselage, for instance. This production system is taking into account the 8 different engineered factory principles that we developed from observations of world-class manufacturing systems and lean manufacturing principles. So as you can see in the animation, we have tack-based flexible production line that moves parts at a known tack time to different work cells. We're orchestrating the work in that we're making sure that we're doing the right work at the right place, the right time, and the right quantity. We're utilizing right-size automation in places where automation makes sense. So here on the screen, for instance, is automated fastening of brackets. And where full automation doesn't make sense, we use right-size automation and semi-automation for workers in the cells. Here you can see examples of pick-the-light bins so the operators know what parts to pick. Their tools are instrumented so they know that for that specific part, they need a specific torque value, and the tool only delivers that exact torque value. Work instructions are projected down for the operator to see exactly where that part goes and at what time it goes on so that we can orchestrate all that work. Another main principle that we're using is what we call work in the strike zone. So this is making sure that we're presenting the worker with all the right tools, the parts, and the work in an area that makes ergonomic sense. So if we can reduce worker fatigue from working overhead or leaning over and picking up heavier objects, that helps us build better quality parts and better and more safe for the workers and for the flying public. I talked about digital work instructions. We're not only projecting them, but we also deliver them in a variety of different devices, augmented reality, virtual reality, mainly for training purposes. And then when it gets down to the actual display of the work instructions, we use tablets, computer screens, laser projection, part projection as well. Conveyance, as Subhash talked about, is not just the parts, but also the tools and the information, which our solution that we'll talk about today really takes into account. And of course, when we create that digital thread, we can integrate quality and logistics directly into it, and ultimately, we can display performance to plan directly to the worker, so the worker knows exactly where they need to be and how they're being measured against that goal line, and their supervisors are able to actively see performance to plan and make adjustments as needed on the fly. Here's an example of a cell that we installed this February, one of our first cells in our engineered factory. So what you're seeing on the screen here is actually what we believe is the first fully automated nut plate machine in the world. Now, those of you that aren't in aerospace may not understand the magnitude of what I just said there, so let me explain. A nut plate, you can see them on the screen there, is basically a nut that's fastened onto structure that allows parts to be taken off an airplane. So lots of parts need to be taken off to inspect an airplane in service, so nut plates are put on there. To give you an idea of how many of those go on an airplane, just for the fuselage that we deliver to Boeing on a 737, there's over 35,000 nut plates that are installed. Each of those has 3 holes, 2 holes that get rivets in them. These have been going on ever since airplanes have been made, and it's roughly done the same way up until this cell here, where a person manually drills holes, puts rivets in there, and manually squeezes them. So you can imagine the amount of labor that goes into that, as well as the opportunities for quality missteps. So that cell there is taking some of our principles, and we brought them to life.
Fantastic. So we spoke about the digital thread. We spoke about the engineered principles. Now let's see how all of this comes together in the solution called FloorSight that's deployed out in the factory floor. We'll divide it into 2 sections, which is more of the front-end component of what this conveyance looks like and what the operators and supervisors interface with. I believe you would have seen in the video a large 86-inch monitor that's touchscreen and 3D enabled. So there's a lot of different components and pieces within that solution that they interface with. And then there's the back-end components, all the different complex data sources and data pieces that we retrieve information from, and we project back to the folks on the floor. So in the middle of this slide, you have an artistic rendition of a subset of machines and what it looks like on the factory floor. On the far left and on the far right, you have those capabilities that we spoke about a little while ago. In the artistic rendition, you see 2 riveting machines, and to the top of that, you would see green panels. Now, those panels, when they all combine together, creates the fuselage that Pierre just spoke about. Now, in order to perform sort of like the subassembly processes on the panels, it has to go through several different cycles and several different steps where minor parts will be added to it. And by the time that it reaches the right machine, it has to be scheduled to run on those machines. And near all of those big machines, you have operator booths where you would have folks sitting down and checking to see if things are running appropriately, if the right jobs are running on the machines and it's completed on time, or if the machine needs to be maintained for some odd reason. Now, all that different pieces of data has to be aggregated and presented back to the operators in real time. And that's what those capabilities are talking about on the sides of the slide. The first is material flow and tracking. As we mentioned earlier, knowing where your material is at all times is the key, so that you can track and ensure that the right orders are being worked on at the right time. And right now, the operators are walking up to the screens and they're able to search for their panels because we have the right tracking technologies applied to it. And Pierre, you have any thoughts on what the business savings looks like?
Yeah, we've seen, so the business impact from this solution, and as far as material flow and tracking go, is we're seeing a marked reduction of labor in that supervisors, industrial engineers are spending about 1/3 less time, or saving about 1/3 of their time, up to 50% in some pockets, of running around the factory, chasing down parts and kit availability. So it's a significant impact to the ability of our people to focus on the actual work and not have to focus on finding parts and locating them in the big factory. You know, the size, just to give you a scale of the size of what you're seeing there on those auto fastening machines, you're looking at skins that are a little bit longer than the stage we're on here today and about as wide as this stage here. So very big skins that are getting auto fastened, and they come from a variety of different sub panels, some 4 to 8 different sub panels that then get fastened together on these machines. And there's lots of different parts, and as I mentioned, over 250,000 fasteners that go into play on each of those fuselages, and we're building about 3 a day. So lots of different parts that have to find their way onto these machines, and the savings is real, and that we can track the flow and where those parts are for the workers.
Schedule optimization, the second capability, that's where all the information from ERP gets extracted and displayed back to the folks on the floor. What should you be working on? How do we prioritize those orders and make sure that you're working on the right order at the right time. There's a lot of different analytics that goes behind the scenes to get that solution completed, but once again, it goes back to constraint management, people, parts, and process, bringing all that logic together. And when operators interface with this, they understand, when they start clicking on the orders on the far left, they start understanding, okay, great, they're color-coded red, blue, and green. Should we be working on something? Should we not be working on something? This is now, a time saving for them. They understand specifically what's needed of them, and they just go about and execute it.
So schedule optimization before the solution that we put in place really came about, and you saw it in the video. If you notice, there was a wooden board with cards in it. So that was the result of an industrial engineer coming in the wee hours of the morning before the first shift started, working with the supervisor to understand what parts are available, where the kits are, checking that against master schedule, as well as machine and labor availability, and creating what we call a plan for the day. All that, at best, with the Microsoft Excel spreadsheet, and normally on a piece of paper, a bar line chart, which we called. In today's world, all that the digital thread has enabled all that information to be in the system, so the system can look at machine constraints, part constraints, labor constraints, and take all of that, bounce it against the master schedule, and develop a dynamic plan of the day, which we can refresh at any interval we want. We're using about 15 minutes. Every 15 minutes we update that so the workers understand exactly what part needs to go on what machine at what time.
Then we have a plant overview. Imagine as a supervisor, I'm walking down the floor and I just need to know, where do I stand today? What's my factory looking like? Do I need to focus on a specific area? Do I need to circle back with some other supervisors or other leads and figure out if there are certain machines that I need to be paying attention to? Having that snapshot, that breadth of information in front of you when you start your day is very powerful. And it's gamified a little bit too. We use 3D so that when the folks interface with the conveyance tool or floor site, they start having a much better experience, and that experience grows over time. And in plant overview, as I said, it captures all the information of inventory. It captures all the information of the parts that are currently placed, staged in front of machines, and even color coding machines themselves with different colors to show if something's running on it, something's not. Should we prioritize those machines?
So a couple weeks ago, we were walking the plant floor, and we really saw that this transformation's really taken place. Creating the digital thread, creating these really nice engineered factory solutions is certainly a technical challenge, but one of the biggest challenges is the cultural transformation, getting people to adopt the tools and use them. So as we were walking through, the very front of the line here is a part kitting area where panels are stacked up onto carts and all the parts that need to go on these machines. That's done completely out of sight, probably a few hundred yards away from where these machines are. And the people in the part kitting area were actually on the screen, and we're looking at the machines that are running. And so we asked them, why are you guys looking at the machines? This isn't your area. You should be focused on the part kitting area. And what they told us was that they've already finished their job, and they were looking at what their users, their end customer, the people they deliver the parts to, they were trying to live those people's lives, trying to understand what their constraints were so that they could better serve them. So that we thought was a really neat and a good example of the transformation that's taken place here, and that's really what the plant overview functionality provides.
Perfect. Finally, machine and job sequencing. This is where a lot of our heartache as technical folk comes in. Like, how do you coordinate and sequence to machines based on the information that they put out, right? How do you sequence the right panel to go on a machine if it's showing you as idle or if it's showing you as down? How do you take the right actions? So in what we've developed in our overall solution is being able to schedule based on those types of constraints, machine constraints, and sequence your job accordingly. There's a lot of complex math and of course, checks and balances and algorithms that go behind the scenes to make that happen. But to the user, the conveyance, it's simple, it's straightforward, and they understand what they need to be doing.
So some of the complexities you saw in the video, you notice big overhead cranes. So in our factory that builds these, we're relying on overhead cranes for movement, and those can oftentimes become the bottleneck in the whole value chain. So part of what this solution provides is the ability to increase machine utilization. We've also developed an app that automatically calls the crane to have it come when the machine is scheduled to be finished. which helps us collapse lead times. And ultimately, this solution really helps us reduce our inventory as well, which is critical, especially with these larger parts and the amount of value that's carried in that inventory.
Perfect. We finally made it. Here's the back-end architecture. Here's all the different components that goes behind the scenes to getting this done. It's very high level. We're not talking extremely complex details. You know, you have to interface with different data sources. We spoke about ERP. We spoke about getting information about inventory. And we spoke about getting information from machines. But you need a platform that is ultimately able to work with all this complex information. So we take all that data and we pipe it to the cloud, where we perform a whole bunch of different, we apply a whole bunch of different business logic and algorithms to it. But it's designed with the evolution of the digital thread in mind, right? It's designed with components like AWS Lambda, where you have serverless architecture, where you think about event-driven computing and you think about event-driven architecture. Lambda's coupled with Python or Node.js, depending on what we're working with, right? And having API gateways, where you interface with these applications, you provide Lambdas out in accordance to what you're trying to, what your objectives are. Having RDS and DMS. When you bring this information in, you want to make sure that it's accurately structured. You want to make sure that ETL process is applied to it. And ultimately, that data gets consumed by the front end, where folks are, like I said, the operators and supervisors on the floor are interfacing with. So you don't want to have lag times between that data point. You don't want to have lag times on how your front end deals with the back end. So that creates a very bad experience. And you need all these services that's available in AWS to optimize that type of architecture. And as this grows, as Pierre mentioned, there's so many other programs that it will eventually set foot on. And as it continues to grow, you want to be optimized for each user. If they're coming in via tablet or mobile, or they're coming in via those big 86-inch screens, to have that ability to scale up and down. So we have applied auto-scaling to the front-end web servers. And there's a lot of different pieces of design philosophies that we've used to develop. But ultimately, when you build a smart factory solution, you have to think broadly. You have to think from the perspective of what happens on the floor, to your networking components, to your different ways of processing that data in the cloud, to choosing the right components in the cloud. And that's ultimately what makes a smart factory solution work. And that has been going on over time. There's one important piece that I forgot to mention, which is RFID. As I mentioned, the material tracking and material visibility. And I don't know if anyone here has worked with RFID solutions before, but having real-time information like that, not just RFID, but even machine data, having all of that data consumed and regurgitated and applied to your different business logic or different components like Python or Lambdas, you want to make sure that that data is accurate. So that's the whole entire back-end piece. From a much broader perspective at Deloitte, we start looking at these smart factory challenges that most people come to us about on a regular basis. And when we take a look at smart factory, we envision this need for having a platform that's consistently reusable and a platform that can be applied to any one of your business challenges on the factory floor. And that's why we have developed a platform called Smart Factory Fabric that incorporates all of those basic components that I spoke about earlier: machine monitoring, command center. And we have some other really good solutions, such as advanced worker solutions, dynamic production scheduling, quality sensing. So these are capabilities that we can bring in on the platform and accelerate your smart factory deployment. You don't have to reinvent the wheel. You can start plugging in your information, customize some of the components in the back end, and start plugging at it and going right away at these smart factory solutions. It's built on some very core principles like ISA 95, the layered approach to zones and conduits. Now, ISA 95, as you know, each one of those layers represent different things. Everyone uses it in different ways, but how we think about it is, of course, 0 through 4, and incorporating cloud into various areas that, that helps us sort of optimize the computational resources and computational needs, and also at the same time, incorporate what you have on your factory floor, right? Could be RFID, could be a whole myriad of different applications that you would have built over time, right? Having all that information aggregated and displayed back to you or conveyed back to you, that's where Smart Factory Fabric shines. And I would like to encourage everyone to come over to SANS Expo booth 2408 tomorrow and Wednesday. We'll be there all day, and we can talk to you about what Smart Factory is, and we can give you a little bit more of a deep dive around some of the specialized capabilities like material visibility and machine monitoring. But we encourage you to come over, have a look, have a conversation with us, and we'll help you drive those or accelerate your needs. Anything else, Pierre?
No, I think that's about all we have. We thought we could open it up. There's mics here for question and answer. Or if you'd like a more intimate setting, we can just kind of step off the stage here and entertain questions up front. But we appreciate your time today and hope you enjoyed it.